Hello, so we need to be able to solve quadratic simultaneous equations. So that's simultaneous equations with a quadratic term in one of them, in one of the equations. So here we have x of 2y equals 3, x squared add 3xy equals 10. So the most ideal way to solve by substitution here. So again, if we call these equations 1 and 2, we're going to rearrange one of the equations, the linear one. So rearrange one of the variables. So let's say x is going to be 3 minus 2y. So if I set therefore sub x into the other equation, I'm going to get x squared, which is 3 minus 2y all squared, add 3x, which is 3 minus 2y, lots of y, it's going to be 10. So then if I expand all this, I get 4y squared minus 12y, add 9, add 9y minus 6y squared minus 10 equals 0. Then I can just clean this up to get minus 2y squared minus 3y minus 1 equals 0. Okay, and then I can solve that quadratic. Let's use the formula. So y is going to be 3 plus or minus the root of minus 3 all squared minus 4 lots of minus 2 minus 1 over 2 lots of minus 2, which will get me minus a half or minus 1. Those are my two solutions for y. So then to find the corresponding x values, as x is equal to 3 minus 2y, that means when y is minus a half, x is going to be 3 minus 2 lots of minus a half, which would be 4. And then when y is minus 1, x is going to be 3 minus 2 lots of minus 1, which is going to be 5. So therefore my solutions are x is 4, y is minus a half, and then when x is 5, y is minus 1. And those are my two pairs of solutions there. Okay, we also might be linking discriminant with these questions. So we have 2x minus y equals 1, x squared add 4ky add 5k equals 0. We need to show this equation, and I notice there's no y in it, so I'm going to rearrange for y. If I call this 1 and 2, y, I'm going to rearrange y in the top equation, so therefore y is going to be 2x minus 1. So if I sub that into the other equation, I get x squared, add 4ky, which is 4k 2x minus 1, add 5k equals 0. Then if I expand that, I get x squared add 8kx minus 4k add 5k is plus k equals 0. And that gets me my equation. And then for part B, I'm given that it has equal roots, which means the discriminant has to equal 0 of this equation. So if I compute the discriminant of this, I get 8k all squared, take away 4 lots of 1 lots of k equals 0. So then I solve for k here, so I get 64k squared, take away 4k equals 0. Then I can factor 4k out to get 16k minus 1 equals 0. Therefore k equals 0, or k is equal to a 16th. But I'm told that k is non-zero, it's a non-zero constant, so k is not equal to 0, which therefore means k can only be a 16th. Then for part C, we are told for this value of k, find the solution to the simultaneous equation. So substituting k is a 16th into my quadratic for x here, I'd get x squared add a half x add a 16th equals 0. Then I could actually times by 16, but I think to make the quadratic nicer, then I can solve it by the formula. So x is minus 8 plus or minus the square root of 8 squared, take away 4 lots of 16 lots of 1 over 2 lots of 16, and so x would be a minus a quarter only. Okay, so that's my x value. So therefore y, well, to find the y value, well, we know y is 2x minus 1. So y, when x is minus a quarter, it's going to be 2 lots of minus a quarter minus 1, which is minus 3 over 2. So therefore my solution is x is minus a quarter, y is minus 3 over 2. And that's only a single pair of solutions, which makes sense because it has equal roots, so only one distinct root from the equation there.